So this is going to be a discussion of an AP Stats FRQ from 2014. This is problem number 1. And we'll just dive right in here. So we've got an administrator at a large university trying to decide whether or not the residential status of students is associated with their participation in extracurricular activities. So residential status is either going to be living on campus or off campus. A simple random sample of 100 students in the university was taken, and each student was asked the following 2 questions. Do you live on campus or off campus? How many extracurricular activities do you participate within? So for the 100 responses, we've got a summary of everything broken down in the two-way table here. In part A, we are asked to calculate the proportion of on-campus students in the sample who participate in at least one extracurricular activity, and then do the same thing for the proportion of off-campus students that participate in at least one extracurricular activity. So I guess the only thing that might be a little tricky about part A here is the fact that the phrasing, at least one, indicates we're going to have to, for the on-campus students, sum 17 and 7, and then divide by the total number of on-campus students. So I've got that work shown here, and then the corresponding proportion. If you wanted to turn that into a decimal, that's definitely fine to do. And then I've got a similar calculation done for the proportion of off-campus students. So I'm taking the number that participate in one activity plus the number that participate in 2 or more, and then dividing by the total number of off-campus students from the survey. Now the little bit that you see down here is from the scoring guidelines. To receive essentially correct for this portion of the problem, you have to have both proportions computed correctly, but you have to have the work shown. I'm thinking that the majority of you taking AP Stats can do these steps in your head or just go directly to your calculator to carry them out, but not listing the calculation that's carried out on your calculator would definitely cost you in part A of this particular question. In part B, it says that the responses are now summarized in the segmented bar graph that we see here. So based on the shading here, we see that the darkest shading represents no extracurricular activities. The gray color is 1, and then the blank is 2 or more. We've got it broken down by on-campus and off-campus. We want to write a few sentences summarizing what the graph reveals about the association between residential status and level of participation in extracurricular activities among the 100 students that were in this sample. So what I notice right away is clearly we've got a much longer stretch of dark shading for the off-campus portion of the bar graph than we do for the on-campus. So right away I commented on that. So the segmented bar graph is showing a higher proportion of students living off campus who participate in no extracurricular activities than those that participate on campus. Now what I did to find the 0.45 and the 0.27 is I went back to where the initial information was presented. For no activities, 9 divided by 33 for the on-campus students gives me this 0.27 value, and 30, no activities for off-campus, divided by 67 gives me this 0.45 for the proportion of the off-campus students that don't participate in any extracurricular activities. One thing that I would be a little concerned with students having an issue with here, I've used the word proportion in this spot, and I think I've used it again in this spot. If you swap out the word proportion for number, the issue you're going to be having is we actually have significantly more off-campus students participating in the survey than on campus. So everything within this bar graph is presented in terms of percentages or proportions. So you'd want to say percentage or proportion. You wouldn't want to say necessarily number. Because there weren't equal numbers of on-campus and off-campus students participating within this survey. So just be careful with your phrasing. Little things like that can cause you to go from an essentially correct down to a partially correct. If you did say percentage here rather than proportion, you'd want 45% versus 27% rather than what I have, 0.45 versus 0.27. I went on to also recognize that the blank sections up here at the higher end, they're very close to the same width. So I went back and computed a couple more proportions, 0.21 for the on-campus students that participate, the proportion of on-campus students that participate in 2 or more extracurriculars, and then 0.18 for the proportion of the off-campus students that participate in 2 or more. So I compared the ones that had the biggest gap between them and the 2 that were most similar to one another. The scoring guideline bit that you see down here, notice what you needed to do to get essentially correct. Response correctly compares proportions between the 2 groups of students for at least 2 of the 3 categories. I have done that. Now look at a few of these scoring notes. A response without any reference to percentages or proportions is at most a P. Well, I do have the percentages, I have the proportions rather, in my explanation, so I am okay there. And then a response that treats the bar graphs as distributions of quantitative variables is going to lower the score 1 letter. So either essentially correct to partially correct to incorrect. What do they mean by that? If you said something about, roughly uniform for the on-campus distribution, or roughly symmetric or skewed to the right for the off-campus distribution, those descriptions of the shape of a distribution are specific to quantitative variables. We are not dealing with quantitative variables here. We are dealing with categorical variables. So I guess a sneaky aspect of this problem that might cause some issues for certain people would be if you're doing the typical description of a distribution based on quantitative variables. That's not the position we're in here. We're directly comparing the different categories, and 2 of the 3 is what you had to do. If you did all 3, that's obviously fine. Honestly, as I read this, I realized I probably should have done some comparison of the 1 extracurricular activity participation, because if this was a problem that came down to the holistic scoring to judge whether or not your half point got bumped up or down, then I probably would have lost it from a lack of having all 3 of the categories compared with one another. I just did the one that had the most extreme gap and the one that had the closest similarity. Now the last part of this is, if you're mid-year in your AP Stats course, you likely haven't spoken about this yet. This is probably one of the last things that you would discuss leading up to just reviewing for the AP exam for a little while before you take it. So part C says, after verifying the conditions for inference were satisfied, the administrator performs a chi-square test on the following hypotheses. So the null hypothesis: there's no association between residential status and the level of participation in extracurricular activities among students in the university. The alternative hypothesis would be that there is an association between where the students live and their participation in extracurricular activities. So the test resulted in a p-value of 0.23. Based on the p-value, what conclusion can the administrator make? So a p-value, the interpretation of it, is the probability, assuming that the null hypothesis is true, that you get a result for your sample as extreme or more extreme than the one that this particular sample produced, is that p-value. So in this case, it's 0.23. Usually what we're going to do in a significance test is we're going to compare that p-value to either 0.05 would be most typical, 0.10 is sometimes utilized, and 0.01 is also used every once in a while. Well, 0.23 is bigger than any of those typical significance levels that you would use in hypothesis testing. So this suggests the survey does not produce evidence allowing us to claim there is an association, right? If I don't have a p-value that's smaller than 0.1, 0.05, 0.01, I'm not looking at a situation that suggests I have evidence to reject the null hypothesis. Now, if you look at my phrasing here, I've got this word here. The scoring guidelines, this particular one doesn't do it, but some of the more recent scoring guidelines use the phrase non-deterministic language. You want to make sure when you're developing a conclusion like this that it is in context, right? So the conclusion has to be in context. So if you look at my second sentence here, I've basically kind of rephrased that the null hypothesis and the fact that I don't have evidence suggesting that I can side with it. So we check all the boxes here. Conclusion is correct. We're not in a spot to side with the alternative. We are in context. and we have written a conclusion that is non-deterministic with a direct reference to the p-value being too high to side with the alternative.